Now that we have reduced rational expressions, we're going to learn how to multiply and divide rational expressions. So we'll start with multiplying. Here are the steps. First step is to factor the numerator and denominator of each expression. Rearrange the terms if necessary to put them in standard form. The second step is divide out to 1 any common factors that are in the numerator and in the denominator. Make sure you only divide out when one common factor is in the numerator and the other common factor is in the denominator. Then you're going to rewrite all remaining factors. So first thing I need to do is factor. There's a lot more factoring to do than in reducing because now I have 4 polynomials to factor. None of these have a GCF, so I'm going to go ahead and start factoring. The first one is a difference of cubes. The denominator is a difference of squares. And the numerator of the second fraction is a trinomial with leading coefficient of 1. I need two numbers that multiply to positive 9, yet add to negative 6. I need to have the same sign, so they both must be negative. So that's 3 and 3. And in the denominator, I have a trinomial with leading coefficient of 1, so I'm looking for two numbers that multiply to 9, yet add to 3. And the factors of 9 are 1 and 9, or 3 and 3. With the same signs, I don't think 1 and 9 or 3 and 3 are ever going to add to 3. So this one doesn't factor at all, which may be a little concerning to some, but notice that the whole trinomial x squared plus 3x plus 9, one is in the numerator, one is in the denominator. We've factored everything out, so now they're all products. These are all products. So because they're all products, I can just divide one in the numerator with one in the denominator. Do you see anything else that factors out? Well, I see this x minus 3 here and then another x minus 3. Now, there's 3 x minus 3's in the top, so any one of them could divide out with the one in the bottom. And then some students might ask me about this. Can these two divide out? Is that a yes or a no? Well, the answer here is no, and the reason it's no is because on the same level. If we had one x minus 3 in the top and then the other one was in the bottom, then that would work. But since they're both in the top, you have to keep both of them. You could write them both out like this, or instead of writing them both out, what we could do is just put a little squared symbol. On the denominator, what else do you have left? X plus 3. So this is my final answer. On the next problem, it looks like I have some polynomials with GCFs. So the first thing I want to do is factor out any GCFs. There is no GCFs in the first one, so for this step, I'm just going to leave it as is. I know I probably could have factored that, but I'll just come back to that later. On the denominator, I have a GCF of x squared, which leaves me with 3x plus 2. In the numerator of the second fraction, I have a GCF of x, which leaves with 9x squared minus 4. And then in the denominator of the second fraction, I have a GCF of 4. Alright, so now I'm going to continue factoring anything that's left inside the parentheses, or unfactored. So the numerator factors into x minus 6, x plus minus 5. The denominator is completely factored. The 3x plus 2 can't factor anymore because it's already a linear term. I have x times, let's see, a difference of squares here. So that's going to be 3x plus 2 and 3x minus 2. And the denominator is already factored completely. So now I look with anything in the top with anything in the bottom. Doesn't matter on which side it is as long as one's in the top and one's in the bottom. I see an x minus 5 that needs to get divided out. I also see a 3x plus 2 that needs to get divided out. I also see, which is a little tricky at times, that there is an x here and an x squared here. Remember, x squared just means 2 copies of x. So if I have 1 copy of x in the top and 2 copies of x in the bottom, once I divide out, I should have 1 copy of x left in the bottom. I think that's it. Well, that's all I can see anyway. Sometimes it gets a little messy, and so you might want to rewrite it, and then once you're done, make sure that there isn't anything left that you've forgotten or missed. In the bottom I have 4 and x. So this is my final answer. Is there anything else that I've forgotten or that I didn't see to cancel or divide out to 1? I think that's it. So I'm good. On my next problem, I have this second denominator is in the wrong order. So the first thing I want to do is rewrite the 7 minus y in the correct order, having all the variables in the front and the numbers in the back. So that gets me negative y plus 7. And on the negative y plus 7, I can factor out a negative 1. And now that denominator in the second fraction is completely factored. Let's see, what else can I factor? Looks like there's a difference of squares here, x plus 7, x minus 7. On the denominator, I have a GCF of positive 7. And on the numerator of the second fraction, I cannot factor anything. So what divides out nicely? Well, I have a y plus 7 in the numerator and a y plus 7 in the denominator. Using a different color, I have y minus 7 and y minus 7, one in the top and one in the bottom. And I think that's it. So what do I have left in the top? Y minus 1. And in the bottom I have a 7 and a negative 1. Well, let's clean that up a bit and do y minus 1 over negative 7. And then probably the best way, even though that's probably that's an okay answer. Even though that's an okay answer, another way you can write it is to put the negative out in front, which is probably a little bit more accepted. Next, we're going to divide rational expressions. So the first step is to change the divide problem into a multiply problem. We already know how to multiply, so if we change the divide problem into the multiply problem, then we know the rest of the steps. So we do that by multiplying the first fraction by the reciprocal of the second fraction. So in Math 0306, when you're dividing fractions like a over b divided by c over d, we can rewrite that as a multiply problem by taking a over b, multiplying by d over c. Notice that the second fraction was reciprocated and the divide sign turned into a multiply sign. But notice what happened to the first fraction? Nothing. So after you've changed it into a divide problem, you're just going to follow the same steps that you already did for multiplication. So this is just one extra step to change divide problems into multiply problems. What happens to the first fraction? That's right, it stays the same. I want this divide sign to turn into a multiply sign. So I am going to have to reciprocate the second fraction. So the numerator 30x to the 6 goes in the denominator. The denominator 30y cubed goes in the numerator. Once I have that rearranged from a division problem into a multiplication problem, I proceed like normal. If there's any factoring to be done, I would do that first, but there isn't. So I am just going to see if there's anything that divides out nicely. I can see that this 30 and this 30 divided out nicely. And on this problem, sometimes students have a hard time seeing all of the terms. If you want to, and this is an option, you could multiply the tops together first. So I have 50x11y cubed on the top, and then 30x to the 6y to the 8th on bottom, and combine the two numerators and combine the two denominators by multiplying and then reducing. Some students find that a little bit more clear. You don't necessarily have to. On my numbers, 50 divided by 30, that reduces to 5/3. I have 11 x's on top and 6 x's on the bottom. After you divide the common x's out, you have 5 left. I got that by subtracting my exponents. And the leftovers are going to go in the numerator because there was more x's in the numerator on the last step. Y cubed over y to the 8. That after you divide out, you'll have 5 left, and they're going to be in the bottom because that 8 is bigger than the 3. So that's my final answer on that one. On the next problem, I want to change the divide sign into a multiply sign. So this divide sign wants to be a multiply sign. In order to do that, I need to reciprocate the second fraction. So the 5x minus 20 in the numerator goes in the denominator, and the 2xz plus 3z was in the denominator, and now it's in the numerator. So what happens to the first fraction again? That's right, it stays the same. So we have 6x minus plus 9 in the denominator. The one thing I am going to change, now I'm not reciprocating it, I'm just reordering the 4 minus x. So I'm going to change that into negative x plus 4 on the same step, just so that I don't have to rewrite it when I'm trying to factor. Now that this is a multiply sign, I want to factor. So I'm going to factor negative 1 out of the numerator. I'm going to factor a 3 out of the denominator. I'll factor a z out of the second numerator and a 5 out of the new denominator. Once I have this all factored, I can see that the x minus 4 factor divides out to 1, and also the 2x plus 3 divides out to 1. Let's multiply all our remaining factors. Negative 1 times z is negative z. 3 times 5 is 15, and that's my final answer. You could also put the negative out in front. Usually if you leave the negative in the numerator, that's fine. Some people find it problematic to leave the negatives in the denominator. On our last problem, we have 3 rational expressions. The first 2 are being multiplied and the last one is being divided. So because it's a division problem, we're going to reciprocate the rational expression immediately after it. So I would like the divide sign to turn into a multiply. So the first thing I want to do is to change the third rational expression to its reciprocal. The first 2 fractions do not have a division sign in front of them, so they're going to stay the same. Next, I'm going to factor all of the polynomials that I can. So we have x and x minus 3 on the first numerator. On this denominator, I have 2 numbers that multiply to positive 12, you add to negative 7. Because the 12 is positive, we know the signs are going to be the same. And because my sum has to be negative, they both have to be negative. That's negative 3 and negative 4. The next numerator is already factored. It's a linear polynomial and there's nothing else to be factored there. On the second denominator, I can factor out a GCF of x. On the third fraction, my numerator now has an easy trinomial, so I'm looking for 2 numbers that multiply to positive 24. You add to negative 10. Because the 24 is positive, I know my signs are the same, and because the 10 is negative, I know they must both be negative. And the 2 numbers there are 6 and 4. And then the denominator 6x is already factored. At this point, I will look for anything in the numerator and in the denominator that are exactly the same factors and that can divide out to 1. So I see an x plus 3 in the numerator and denominator. I also see an x minus 4. And last one I see here is one of the x terms with one of the x terms. I think that's all I have, so let me go ahead and write out the answer. And if I missed something and we need to divide out again, we can do that. please be careful. The x minus 6 and the x plus 6 do not divide out to 1 because they are not exactly the same. Now that I'm looking at this answer, it doesn't look like there's anything else that could divide out, so I know that I am done.